There we go. There we go. Perfect. So we'll start with the session. Thank you so much, Madhusmita, for doing this for us. Welcome, everybody. Welcome to another Thursday session. This session has been organized completely by our Hyderabad Council that is in attendance today. Our speaker today, her name is Madhusmita. Is a distinguished engineer at IBM. She also is a master inventor with about 25 years of experience, and she specializes in architecting complex, high-impact solutions across cloud, AI, and a deep expertise in Watson technologies, NLP, machine learning, and deep learning. And with all of that, she's going to now walk us through how we can architect our applications using Agentic AI. So over to you, Madhusmita. Thank you so much for doing this session for us.
Thank you, Arushi. Thanks everyone for joining. And let me, sorry, 1 second. I'll stop sharing and reshare. Because includes. Is my screen visible?
Yes, it is visible. Yeah.
All right. So what we are going to do today is agentic AI architecture, right? I don't know how many of you come from the solution architecture or architecture background, but that said, as many of us know, or as many of us are actually selling through this AI era, every now and then people keep on talking about agentic AI. Okay. So I thought this particular topic would be very, very interesting for all of you. Uh, Today's agenda, what I wanted to do, introduction, how exactly the architecture has shifted. When we talk about agentic AI, how we bring it to life, right? What patterns do we follow? Many of these things you would be hearing, and many of these things you would be actually listening to every time there is a session happening. But let's go a little bit into deeper and see what exactly we would do, and then how can we operate it safely. I know some of you mentioned about tools and technology. So when I touch upon the operating it safely, I'll also quickly touch base on the tools part of it, tools, technologies, what is available in the market, so that you can say. And then I thought that it might be helpful to give a client story so that you all can actually correlate to your business problems and things like that. So before we get into that, I know we are almost at the end of the this thing. So I will just show you this particular video, right? I just wanted to start with this video. And I know the metrics evolution, very famous. All of you know this. Right. So I'm sure you all, I don't know if you can, if you could hear it or not, but that's it. The reason I thought it would make sense to have this is you must have seen this movie, Matrix. The Geon Doc battle scene is one of the very famous scenes. What you would see that instead of one giant, which actually giant computer, which actually tries to destroy destroy everything, when it hits that command, there is a swarm of agents who are actually coming in and taking an action. Okay. So these are the agents that actually, who are actually coming in and starting to take action instead of just one. So that means there is a group of agents or group of the team which actually works towards it. right? So how exactly all of these things come into picture, and what is that? I mean, they have to be doing it in a coordinated way. Otherwise, it would not really, function well as you see in that movie scene. And similarly, in the real life scenario, if you want to really do things, it has to be orchestrated well. So that's exactly where your agentic AI architecture comes into picture. Moving on, we will do one thing. I'll try to close it by 5:45 so that if you have any questions, we can take it up. And I'll probably skip few slides if because I think many of these things are obvious, right? I wanted to keep the flow so that you all can see and correlate. So the evolution of software architecture, if any of you are like me, who is like a old timer, 99, I started my career. So you would see that time all that we knew is the monolith desktop applications. Then some of us started working on client server architecture. Then I don't know how many of you again know struts, MBC patterns, and all. That's where the entire architecture came into picture. Then sometime in 2004, 2005, if I correctly, the SOA architecture came in, service-oriented architecture, that completely shifted the way the architecture will look like. So protocols, the way it has to be defined, how exactly we define our APIs and so on. And then from SOAP to REST, then came the microservices world, microservices architecture, along with the cloud native serverless. It all happened because the way the infrastructure platform evolved from single systems to cloud, to different models like infrastructure as a service, platform as a service, or software as a service, and so on, right? And right now, as you see, from 2000, I would say 2020 or maybe 2015, 16, that time frame, you would see that AI based applications along with the cloud uh, came to life. And when we talk about AI that time, it was like small pieces of AI solutions. Overall, there is a cloud solution available, there is a small AI component that is available. But now it is all more of automation, more of intelligence, and that's where the agentic era has begun. Right? And why is it so different? What is that agentic era and why the agentic architecture? So, this is something that I thought from a business point of view. If you see, what did we initially focus on? We started from the legacy systems, desktop automation. Then when we talked about the 2015, 16s, we started looking at the RPAs, robotic process automations, where we started looking at how can we bring in our RPA systems, RPA automation, and so on. And then we started looking into the cognitive automation, where some amount of engagement, virtual assistants, chatbots. In fact, if you remember the COVID era, 2020, 21, or yeah, 2020, 21, almost everybody launched a virtual assistant or a chatbot, right? And they realized that okay, a lot of things can be done in virtual assistant and chatbots. And that's when the next layer came in, that is where the intelligent automation that came into picture. And then with 2023 timeframe, ChatGPT came in, and that's where the generative AI era started. And it actually started in a way that the way the progress should happen, instead of the slow progress, we saw that within 2 years, things were catching up. Almost everywhere you're talking about generative AI, you're talking about agentic AI, you're talking about AGI now. The way the AI revolution happened last 2 to 3 years have been very, very disruptive. But what it means is the way the customer interaction, or the way the business workflows, the business process workflows have evolved, it demands that we start relooking at things in a very different way. And that's exactly where the agentic AI plays a very important role. In your enterprise or in your organization, I don't know how many of you would agree, people are talking about digital agents along with the human. So when you talk about a project structure, when you talk about a team structure, it is no more just practitioners working in that particular project. I have a project manager, I have a tester, I have a developer, I have a software architect. It is also including the digital agent who can probably do some of the work and then some of the niche work actually lies with this thing. So that's where you would see how the business workflow has evolved and how it has impacted our daily to daily communication, daily to daily workload. So what makes a system agentic, right? We have been talking about, okay, agents. So the moment we talk about the agents and why is it so different? Why are we including the agents in our team structure, right? So you would see that something called as predictive classification, supervised AI ML, where we did the training data sets, which said that, okay, learning data sets and which is on learning data sets. There are multiple ways to train your data sets. We spoke about machine learning, traditional machine learning models. Some people called it, some people brought in the deep learning models and so on. What did we do? We did prediction and classification. That's all. Classification, again, different types of classification, different types of prediction, but yes, that's what it was limited to. Then came the Gen AI era. Generative AI, when it came in, we started looking at, okay, how do I generate text? How do I generate images? How do I generate videos, audios, and so on? So, and we started looking at the prompts. We started looking at the LLMs. Then we spoke about context engineering, like how can I make my prompts more contextual? What happens? And then finally, now it is the agentic AI, where we are trying to say that it is an evolution, like the way human being has evolved from the earlier species to the current one, where we have a brain, we think, we act, we plan, we have a goal to achieve, we live in certain way, we have our we have planned few things for ourselves and take necessary action. If I met with something where I need to take an action, I would take an action, right? So that's where the agentic AI, similar to the human beings, it has evolved. So it is more, it has a memory. You can talk about short term, long term, episodal, whatever, right? Procedural, whatever the standard terminologies. It has a goal, it has a plan, it can take an action, and it reflects and responds. So that's where the agentic AI comes into picture. And every agent runs to the through the same kind of loop: perceives, reasoning, acting, then reflecting, and so on. So when you think of an agent, you actually think of all of these things. And the reason I'm sharing all of these things, it is just a precursor, because when we get into the architecture, we need to understand what is the responsibility of my agent. I don't want to build an agent for everything, because infrastructure is expensive, platform is expensive. Managing these agents or developing these agents also need some key skills, right? So I don't want to build an agent just for the goal of it. So I need to think of in a way that what is the responsibility of an agent? Why would I build an agent? And what exactly is the what exactly the agent does in the ecosystem? So that's where the every agent runs the same loop. Now, when if I talk about the enterprise, this is for people who are more from a business background or from a consulting, where you actually go and define solutions with your clients for them. So you would see that application of AI agents are a function of both the decision complexity and what is the risk exposure that you want to give in, right? So if you see that in the left hand side, the vertical row, these are the risk, and the complexity is in the horizontal. So you would see that the independent actor, there is no oversight, right? One, it can do everything on its own. Executor, it needs still little bit of monitoring. Then the third is the operator, the AI as operator, which actually needs some edge case approval. So for example, if I'm running an agent in the production system, and the system actually expects that I would do this kind of thing. And in case if something like this happens, let's say, or data loss, maybe it has to remove that particular record. So here it actually, operates that process. I mean, it can find out that, okay, there is a challenge and I can remove this particular record. But have I given is it safe enough to give a agent to remove a record from production database in case of a risk condition like this happens? So in that case, probably we need to have a human review in the process. So it can trigger probably a notification to with your Slack or with your phone or with your Teams chat or whatever it is, right? And say that, okay, this is what is happening and the system is going down. I see your data issue and this particular thing I have never seen earlier. Shall I go ahead and delete that record? So this is a very, very this thing where we need a approval, and it is a very highly complex one with high, this thing with a very, very highly complex one which needs human reviews. Similarly, if you see the collaborator, which is a suggestive action that it can do, it is a medium complexity with a medium risk, and where the assistants do not have any decisions, you can actually build an assistant for your everyday work, responding to emails or suggesting. I mean, I wouldn't say responding to emails, I would say suggesting correct response for your emails, or it could be very simply summarizing your email that you are actually going through, and so on. So there are multiple things where assistants do not need any decisions and probably pretty low risk and low complexity. So with that, that's where I just gave a view of what is an agent, how the architecture has evolved, and how agents actually, why agents are important, and why the industry is moving towards the agentic AI. Let's move on to the structural blueprint of an enterprise agent, right? So if I have to think very, very simply, forget about the whole complex agentic architecture paradigm that we are talking about. If I have to think about an agent and in the enterprise, what would I think? It's the same thing. The way I would put it is start thinking what would your component would do in a standard architecture model, or if you're defining a microservice, what is the responsibility of that microservice? So here it could be the interface where the intent enters. It could be like any of the channels, chat, APIs, event trigger, anything. Orchestrator, planning, task decomposition, control flow, so any of those kind of things where we do a business process orchestration. Then because it is an agent, it is not an assistant, a very, very definitive stage, right? Reasoning of what kind of decision I can take. How can I do why am I taking the decision? And then to support all of this, you need a memory and tools. And across all the layers, you have a security and governance, policies, compliance. Now DPDP has come into India, then your HIPAA and GDPR, all those laws are still there. So all the security and governance policies are, very, very important from an enterprise agent. Now, this talked about the standard agent. Now let's put it in terms of how exactly I would put from an architecture perspective. Now, if I have a what happens if I have a complex problem and I think, okay, if I'm a human being, what would I do? I would start dividing that problem into different tasks. I would start some things I know, some things I do not know. Then I would go and ask a few people for some of the things. I would find maybe YouTube, I find Google, I find Udemy, wherever I find related knowledge, and then I would start, taking some actions. That's what I would do as part of the process transformation. Now, when I'm talking about an assistant, what I would do, I would actually do the related knowledge that I just had. So there I said, okay, I'm a human being. I mean, I can do everything, but I need little help, because I can probably build an assistant which can go to Google and just start giving me relevant information. So I don't have to manually sit and search every information. I have built an assistant. I gave you a query. I gave a prompt. I gave the context, and based on the context part of it, it went and it started searching. So that's where it started getting the relevant knowledge. Then the next part where the agentic piece comes into it, comes here. So everything that I was doing, I actually want to offload it to an agent, and I want to come in only when there is a specialized knowledge, or there is a special approval, coming, and that I need to put. So very simply, if I have to put it in a family structure, it is like making your children independent, and they can just come and ask us only when, ask the parents only when there is a specific need, right? So that's the only thing that I'm doing as an approver. I want my children to do everything on their own. So I have enabled them. I have given them all the tools, all the these things, all the necessary support, whatever is needed. And instead of me doing everything, I want my children to do that, right? And I hope that clarifies on how exactly this whole thing. So now we have got all of these things, right? We have said that what is an agent, how will it take action, what happens, and how the things are and what is the key components. So when I look next, if I have to say, what did you do? We actually started with an assistant-centric architecture so if you see, we started with small assistants. Here, if I see find related knowledge, what did I do? I brought in a assistant. I would say, okay, can you also send an email once you have got it, draft that email? Fine. That is also an assistant. I can have multiple assistants, right? I can do lots of assistants and I can, but what happens in that case? Fragmented. These are all individually small assistants that I built in. There is no unified this thing. And when I'm talking about the business process, it is, I cannot say that it is fully automated, maybe semi-automated, but there is a lot of scope. And do I really need to have my business process with so much of dependency? Can I smartly think of automation in a way that wherever the human intervention is not needed, can I do that kind of a automation? So that's where you would say that multimodal, multi-agent unified, implementation would come in. So you would have all your, user experience coming into picture. You have your tools, you have reasoning, you have planning, you have disambiguation, intent identification, all those kind of agent coming and sitting here. And then you have different types of agent, because you decided that, okay, these things I have now practiced it, I have put it, and I will just have this. Then I will, and to enable these agents, I have to do something, right? They cannot just perform on their own. They have to talk to other people, other systems. So that's where you would see that, okay, there is a model gateway sitting, and it can talk to the knowledge graphs, it can talk to the APIs, it can talk to the database systems, it can talk to the third-party systems, whatever. So this is where the multi-model, multi-agent unified implementation comes into picture. So this is where the architecture, the whole architecture that we are talking about, that how do I bring? So we need to start thinking in that direction. The moment I start thinking about a production-ready architecture, I need to start thinking about how do I build it so that, and what are my agents, what are my life cycle, how do I make sure that they communicate well, they are placed properly in the ecosystem, and so on. So that's what is the this. And when you talk about agents again, I thought it might be interesting. Don't look for everything to be custom built. The same thing, the way we would actually do a software selection, wherever it is possible, look for pre-built agents, then go for the custom built agents, and then multi-agent orchestration is something that we are actually focusing. So our focus is on the first is whatever is available. We are not going to reinvent the wheel. We go for the pre-built agents wherever it is possible, and then custom, and then the orchestration. And this is where the whole of our focus, lies in, right? So core components of an agentic architecture, the models, orchestration, and tools. That's what I have been talking about. I mean, I don't think this thing. There are multiple challenges when we talk about the tools. Uh, Fragmentation, data silos, integration, tool discovery, security risk, all of these things. And to address this, we said that, okay, we can have model context protocol for the tools and in this thing. But and at the same time, for the agents to agent communication, we can have agent to agent communication protocol, A2A, right? So MCP is for the tools integration, agent to agent integration, we talk about it. So you see the standardized protocols and so on. So these, the tool challenges are actually very nicely done, or very nicely addressed through the MCP. Then when we have the tools, if you see this is where the tools and then the MCP. So this is how the architecture evolves. If you see, if you map it from the first slide of architecture, we said that, okay, there is a UX layer. From there, it goes to orchestration, and then the models are there, and the tool supporting, and then all of them talking to the internal of it. So this is where the database and all this, and that all is enabled through MCP. Now, what are the challenges with models? Models, I mean, if you see the market, there are so many vendors, so many. And I mean, everybody is offering their best. It's not like, okay, I may use Claude today, I may use Granite for something else, or maybe GPT-4 or GPT 4.5 for something else, and so on. So what happens is, the moment I look at the models and I am dependent on a specific model, I'm also getting into the vendor lock-in, right? And some of the models are excellent for certain work, for some of the models are not good for that work. So how do I break some of those challenges? So if you see this, this is where the model gateway, right? I mean, this is from IBM model gateway, but yes, you can see the model gateway, and it can actually talk to multiple areas. So that is another way. Like, if you remember the if you know the API gateway, how exactly it routes the various APIs and things like that. Model gateway is almost similar, where it actually talks to the various models. It can actually do the kind of routing, reporting, the kind of guardrails that it needs, rate limiting, how many tokens you want to use, so and so on. So that's where the model gateway comes into picture. Now the whole architecture system has evolved. See, models, we talk about orchestration. Orchestration is more in terms of our business processes and the tools, and then how the tools piece of it integrate, and so on. So that's how the overall now, to support this, there are multiple frameworks also available. Like, you have this one, so if you see this, I spoke about the memory, the agents, the tools, the planning, and so on. So all of those things, again, we can use any of the LangChain or LangGraph kind of this thing, agentic frameworks. And again, as I said, let's not reinvent the wheel. Let's pick up whichever we have access from an enterprise architecture perspective. I mean, in your enterprise, pick up the one that your organization has approved, and which is, of course, cost effective. You want to try something on your own, maybe try with Crew AI or LangGraph or LangChain or some of those things, or even AutoGen for that matter. So some of these things are already available, right? So these are the various frameworks already provided. Pick up one of the agentic framework and let's get started on that. LangGraph agents, this talks about the nodes, edges, and so on. Similarly, this is the Crew AI. The similar way, it is just that you would, based on your convenience, based on your familiarity, and of course, from the enterprise alignment perspective, you would pick up one of the frameworks. Now let's look at the agentic AI architecture. So we talked about the overall architecture, the layers, what are the key components of an architecture, where they play a role, how to bring in something like, for example, the model gateway, what is the importance of it? Or we talked about MCP and so on. But if you see this, there are few things we talk about in terms of patterns. And again, this particular pattern or something that is something that you would need to keep in mind when you are yourself designing the architecture. Okay, so like single agent network, and if you, I don't know if it is visible in your screen, maybe you want to maximize it. But if you see this, single agent is like single LLM agent doing everything. Network, it's a network of agents. Supervisor, one main supervisor who is ordering the other agents, and they are just doing this thing. Supervisor as tools, again, they're talking to the MCP, and then getting all the things done. Then the hierarchical, there is a supervisor. It gives it is like account executive has multiple project managers, giving tasks to each of the teams, project teams, and each of the project teams are actually working under each project manager, reporting it back to your account exec. And then the custom, it could be anything, zigzag pattern, whatever you want, based on the this thing. But which one is the best? Again, depends on the what do I say, on the business process, on what you want to execute, and so on. It is not like I can just pick up and say, okay, I know supervisor, I love supervisor isn't, and I would want to use it. So let's go a little bit more in terms of the this architecture patterns, right? So what we said, single agent, right? User requests, plans, gender tasks, does things. So everything is single agent. Multi-agent supervisor, you have a supervisor, it sits here, gives some of the tasks, agents are actually able to execute. It actually can take action, it is just providing a direction to them. Similarly, for hierarchical, as I said, supervisor gives two more under him. There are two more supervisors, and they are actually giving it to the agents. So then in agentic architecture for specific areas where we need human in the loop or HIL, we would need to bring in, especially where we hit a breakpoint, we need a approval. So for example, there is a transaction happening in your bank and your daily limit is 5,000 or maybe 50,000 rupees, and you are a high value customer. You have a lot of money in your bank. It is like maybe based on the bank's this thing, right? But suddenly there is a request that has come in for, say, let's say 10 lakh, day withdrawal. Now, uh, your transaction loop, if you have an agent which actually is monitoring the transactions sitting in your bank account, sitting in your bank account withdrawal process, it would say, okay, I mean, this rule is failing. Okay, this particular rule is failing that the daily limit is 50,000, even if it is a high net worth individual, HNI. And but he has a lot of money. He has actually some 1 crore. But do I allow this? Can this be authorized? Even if he has, and there is a condition that in a high net worth individual, it can be evaluated case by case, right? So in this case, can we allow that person to withdraw 10 lakh? And we don't know. It could be a fraud, right? It could be like nowadays, so many digital frauds are happening. It could be a genuine case. It could be a fraud, right? So in that case, it could happen that it would go for an approval process. And then maybe somebody from the call center calling up and confirming that, yes, have you requested, should we approve, should we not approve, or whatever it is, the process. But very, very specific business process oriented ones where you would need to, where a human involvement is needed. And so that's where the, human in the loop must be thought about. Now let's move on to the multi-agent. So we have been talking about single agents and supervisor and all those things. Multi-agents, again, network or the horizontal, hierarchical, vertical. So there are multiple use cases like the here it is ideal for collaboration, problem solving, peer-to-peer learning, or decision making. So we need to have some kind of a conversation to have this horizontal or network kind of a kind of this thing, right? Kind of multi-agent pattern. Similar. So again, it's all based on the use case that you are trying to solve. Sequential workflow, parallel workflow, or self-healing kind of a workflow. So where what happens in case of a sequential workflow is one after one after one, you would actually do. You cannot do it. That's where the sequential workflow would work. And if you see the parallel workflow, you would see that, okay, things can be done. Oops, sorry. Parallel workflow, you would see that parallelly all of these things are working. Multiple agents can be working together, and then their output can be summarized or their output can be together provided, right? So that's where the parallel workflow. And in some cases, the loop self-healing, where it is an iterative process. One agent does something, it actually evaluates, does a error correction, self-healing systems. So one of the important use cases, if you see many times the infrastructure, the cloud related, your infrastructure goes down, and there it actually tries to find out a problem. It tries to self-heal itself and then brings it up. So those kind of things in the production systems can be very, very helpful. So these are kind of multi-agent patterns. Then there is a router pattern where it can actually route to different workflows, or it could be an aggregator pattern where multiple inputs are coming into the same agent and then it tries to process it as it wants. It could be a combination also, router plus aggregator or custom. That's what we were talking about. So these are all various patterns that we use for your this thing. Now, what is the what does what would work for me, right? If I have to look about I have to talk about a business process. The first thing I would say is look for the simplest topology that works. Don't worry about, okay, this is something that I would do. This is something that is very complex. It looks very nice on paper. forget about it. Let's see what is the simplest topology that works. That's exactly what you should look for. So some of the examples like single agent support tries, document Q&A, those are the for some of those things, single agent is a better one, or is like you can think of the single agent, I would put. Similarly, supervisor plus worker. So if you see research, multi-step pipeline, different groups of people or different agents are there. So that's where supervisor plus workers. So maybe, for example, solution architecture, the SDLC life cycle that we build using agents. So there we can have if I'm building a solution architecture, I can have a testing agent who can build for me the test architecture, which infrastructure, because these are all needed for specific predefined or knowledge that is very important for a specific domain, right? So that's where I can think of some of these, or even peer swarm, where multiple agents are able to negotiate or complete towards a shared goal, right? So that's where there is no specific fixed hierarchy, but they would actually work together. So that is where the peer swarm. So see what works for your business process or for your solution better. How do you operate it safely? Again, that's exactly where non-functional requirements come into picture. As I mentioned, the first itself, bind the action space. Very important. What is the responsibility of the agent? What exactly it does, right? Hard limits, cost, time, everything. Put a limit to that. What happens if there is a irreversible action? Is it causing any kind of negative situation? Or can I, if there is a negative situation happening, can I intervene it easily? That is the other thing, right? I'll give you a very specific example for this, why I think make intervention easy. In one of the automotive companies, what I know of in the manufacturing floor, um, there were these small pieces of the parts of vehicle that actually goes, right? And it was a quite a big news some time back, maybe 4 or 5 years, or I don't remember exactly the year of which it was reported. But if you see that, so all of these things were going in a belt, right? And something happened, the belt malfunctioned, and the agents were actually working one after another. It will all it's all fitting, and then it goes typically how it would work. And you can actually compare it with any kind of manufacturing process, right? Any kind of manufacturing thing, small thing also. And now the supervisor who is actually observing them, he realized that there is a malfunction in the belt, and if it doesn't stop, there will be a problem. But these are all automated digital agents that's going on. So since there was no way to stop it, he put his hand. Okay, and now you can imagine what happened. He lost his life, right? So very important. There has to be a way where we should be able to stop intervention easy, identify that there are problems, make necessary actions, human in the loop. So some of those things, are critical for the successful execution of a agentic AI solution. As I said, tools and technology, this may not be the comprehensive because the market is evolving. There is a lot of people, lot of areas in this. But if you see this, this is all, generative AI, the landscape, and plus agents. I mean, again, agents would be something that you would see in your organization, the pre-built agents or the custom build that you would do for your need. But if you see, there are a lot of frameworks, lot of close, infrastructure, the platform, the compute, everything is available. And there is a bunch of people or key niche players in this market. So based on your enterprise, you can choose that. Uh, One more thing, traceability, auditability, logging, monitoring, all these things are non-negotiable. If you can't trace a decision, you cannot trust it. Agentic systems fail differently than a normal software, not with a strict trace, but one small decision, wrong decision, can actually impact heavily. So make sure that it is all traceable from the source system to the destination. Make sure it is evaluated and monitoring. So that is another thing that you should look for when you talk about your solution. So I think so, and this is the, as I said, what actually breaks in production. These many things, right? And especially since agentic AI or AI solutions depend on heavy infrastructure, there could be a silent cost creep and so on. So, what this means, you make sure that you have you and your organization is able to go step by step, but at the same time, do not compromise on the non-functional aspect of it, right? Uh, so bottom line, if I say architecture is the difference between a demo or POC to a version to a system that you can trust, right? That's the most important difference between architecture and system. That I'll take quickly 1 more minute just to show, and then I'll open it for the questions, right? So this is for an automotive client. The industry is, evolving for the automotive to from mainframe modernization to agentic AI. So it is like majorly automotive manufacturing committed to delivering brand promise, competitor advantage, and so on. Included the demand supply management. If you see demand supply management, logistics team, supply chain operations for the automotive, all these were the key stakeholders. And the ask was to have this in the supply chain operations in the North American division of this particular client. Now if you see digital products, supply chain, the core domain data, then the logistics, and all these are the ecosystem of the ecosystem for the client, right? So all of these things, when we looked at it, we started looking at it in terms of the how can we improve the processing of the vehicles. And the client processes 10 million vehicles annually through its global supply chain. Advanced technology and AWS cloud services, and DSM agentic AI powered solution that supports the DSM users in automotive distribution, streamlining the inventory and so on. That's where the agentic solution was brought in. And I'm just going to tell, the 20 to 30% improvement in the delivery, right? Timeline, improvement in the productivity, and of course, the rest all are given, right? So what we did as part of this thing, this is a small example of the architecture. If you see the supervisory micro agent orchestration layer, which was built on LangGraph, then these are all the things that you can map to the example that I had shown earlier. Then we did the functional AI agents and pipeline, and plus the various other agents, brought in the data layer, because without that it would not. And you would see that the MCP server, A2A server, A2A client, all those things are in place. Plus, we had this observability and DevSec on MLOps to make sure that all these things are taken care of in terms of traceability, monitoring, and so on. So that was the logical architecture. With that, I will take a pause here and open up for questions.
Hi, Madhusmita. Thank you so much for covering that. Could you also touch upon the guardrails and the security?
Yes. Okay. All right. Okay. So for the security of the agentic AI solutions, right? Um, I wanted to highlight a couple of things. It is just not AI security. How would I do when I define the security for a agentic AI architecture? I have to look from a different point of view. Overall application security, is my application secure? Overall data security, the information that I'm actually processing, is it secured enough in terms of the masking? Because some of these actually talk to the sensitive data part of it, masking of the data, the way that the information is actually getting processed. Plus, so I talked about application, I'm talking about the information or the data security. I also have to have a user-based security who can actually authorize, who can get authorized to work on behalf of the agents, who can actually access the agents, and what roles and the responsibilities, as I said, has the agents do. So can I have a security system for the agents itself defined in my security component? That is something that I would need to look at. So especially for the agent to agent communication and the tools, agent to tools communication, I would also need to look at the different protocols that is already available. So MCP, when I talk about the MCP protocol or the MCP gateway and the model gateway that I was talking about, you would need one of the critical guardrails is you would need to have the security and the features of those things in place. So in your MCP gateway, you have to build in those security components, plus the communication that happens. So because MCP can talk about the APIs and so on. So how do you would need to bring in those security tokens like the SAML or the or OAuth kind of a token, those kind of things. So it actually looks at the overall enterprise security picture. If you're talking about the overall agentic AI architecture, I don't want to bring in a separate agentic AI security, because here the whole agenda is how does it sit or how does it fit into the enterprise architecture, landscape. But if you specifically talk about the agent security part of it, then yes, we have different no different techniques and the different techniques that we can actually think of as part of the agent security, which are also, again, there are dedicated tools and technologies available. So for example, I know Watsonx Orchestrate that IBM has. It has its own security components, and it helps in the agent security piece of it. Does that answer your question? Any other question?
I think people are trying to grasp all the information. Anupama, thanks you for covering the security aspects. I see a few claps. If anyone has any questions, you can unmute now. We have another 8 minutes. Oh, it was a very insightful session. Yes.
Okay. Thank you.
It's for the wonderful session. There is a lot to grasp. But will you be sharing the deck, or will the recording be available for us to rewatch? Because
The
uh,
recording will be available on the Anita B YouTube channel. You can find it
okay,
there in about a week's
oh,
time. Yeah.
okay, thank you.
Anything else, folks?
So how many of
Keep
you
that to
use?
add actually questions on MCP servers when Sindhu has done on the RAG. So he is an expert who can speak about. Shoot out the questions. A lot of people did ask about the MCP servers when Sindhu has done the session somewhere in May.
Maybe we can do a small demo on how MCP gateway works and how MCP, we invoke and so on, right? Was it done already?
No, it's not done.
It's not done, right? Okay.
Yeah. Please shoot out the questions. We have a very esteemed guest today. Please.
I think people also have access to your LinkedIn, which we've also tagged. So if now is not the right time, they can also reach out to you via LinkedIn. Is that okay?
Yeah, yeah, absolutely. Anytime. Yes.
Great. All right, then. I think in the interest of time, then I will wrap this up. Thank you so much, Madhusmita. We're really, really grateful. This was quite insightful. And like I said, the recording will be available on our YouTube. And folks usually go to the recording and then we'll go to you with questions as well. So thank you so much. Thank you for the Hyderabad Council for hosting this event, to Anupama, Anuradha, Divya, Aparna, everyone that's here from the team. Yes, Karen. I
Thank
think
you once
Karen had
again
raised.
for your valuable time and look
Thank
forward few
you.
more sessions. Thank you.
Sure, Anupam. Thank you. Bye. Bye.
All right. Thank